Seasons can be quite drastic on this planet. Winters are cold enough for me to deck out in all of my knitwear, except for today, of course, but summers are so unbearable for me that it makes me want to peel off my own skin. All of this is thanks to just a little tilt in Earth's axis. Can you imagine that? Just a tiny tilt makes a huge difference in the climate and whether lakes are frozen over or not. So when the sun was young and just getting riled up with its nuclear fusion, how were we able to maintain a warm climate? Hi, I'm Seti, I'm a PhD student in astrophysics, and today we're going to be covering the faint young sun paradox. This is part 3 of my Astronomical Paradoxes mini-series, and it is one of the only paradoxes that actually has a space science and planetary focus, which makes it unique. The faint young sun paradox has been solved thanks to the boom in climate science since its creation in 1972 by Carl Sagan and George Mullen. The creation of the paradox, that is, not climate science. See, when the sun was just starting up nuclear fusion, it wouldn't have been as bright and as luminous as it would be today. In fact, its luminosity would have been an estimated 70 to 80% less than it is today. That's quite important. Luminosity is basically a power output and is really significant for the conditions on Earth. So if the sun were only operating at 70 to 80% its output, we shouldn't really have had liquid water or even the right conditions for life. However, Sagan and Mullen are kind of making a big assumption with the creation of this paradox, that Earth has stayed the exact same, specifically its climate has stayed the exact same throughout these 5 billion years. And no, it really hasn't. We can look to other planets for clues, specifically Venus, which its atmosphere is 96% carbon dioxide. Today it's a hellscape, but perhaps when the sun was just starting up, its atmosphere would have been a lot more tolerable. But carbon dioxide is a very good insulator. It's called a greenhouse gas for good reason. So it traps in heat. So as the sun would have grown brighter and brighter and hotter, all of that heat would be getting trapped within the atmosphere, making it a total hellscape. And that is why no mission that has ever landed on Venus has come back alive. The insulating properties of greenhouse gases means that even if you take away the sun right now, the temperatures on Earth would still stay warm for a little bit. So perhaps our answer lies within carbon dioxide. If we had such insulating greenhouse gases earlier, so if the climate looked a little bit more like Venus's, maybe we could fill in that temperature gap that the paradox is missing. Give time for things like plant life and plankton to form, which act as really big carbon sinks, depleting the atmosphere of its carbon dioxide and hopefully refilling it with oxygen. The main working theory, which is now heavily accepted within climate science and geology, supports the carbon cycle. This is a really complex network made up of plants, algae, plankton, soil, the bodies of water like the oceans and marshes and swamps, all of which exchange carbon dioxide with the atmosphere and embed it within the crust of the Earth. One of the biggest parts of the carbon cycle is the ocean, or the deep ocean. This is where carbon gets dissolved and it sinks down to the bottom of the ocean as sediment, or it might also get used up by phytoplankton. Carbon sinks are still sinking carbon, and they have been for a very long time. A lot of the evidence can be found just by digging up parts of the crust and see the carbon levels change over time within the sediment. So there is really strong evidence of carbon being much higher earlier on and having been captured and sort of sunk into the crust of the Earth, meaning that it is very possible for greenhouse gases like carbon dioxide to be responsible for the sustained warmth of Earth. And for that reason, the faint young sun paradox is now an X-paradox. It has been solved. Thank you very much for joining me as I discussed this today. It was a really insightful paradox because this is an area of space that I don't usually get to cover in my own studies. And I'll see you in 2 days' time for part 4.